All right, so welcome to our journey into quarks and to understand what those types of particles are. Well, quarks were a very important discovery because that was kind of one of our first entries into the fact that there's a zoo of particles inside the atom, okay? And so protons and neutrons are made of quarks. When we smash them together, we found these smaller particles inside of protons and neutrons, and we named them quarks. Okay, and quarks actually build more than just protons and neutrons. There's other particles that we just discovered as well. And all those particles that are made of quarks are called hadrons. So that's something that you need to memorize and make a definition of. A hadron is any particle that contains quarks. Protons, neutrons, mesons, etc. contain quarks. Okay, and there are 6 different types of quarks. Here in this picture, I see a UUD. What that means is in a proton, there is an up quark, and a down quark. So in protons and neutrons, they contain a combination of 3 of these quarks. You have a total of 6. And if I look at these 6 quarks have flavors, okay? So each of these is a different flavor of a quark. It's strange, but they've created these names, these particle physicists, to be able to try to understand this whole stuff. So every flavor, up, down, charm, strange, top, or bottom, those are 6 different types of quarks, have different properties. And if I take a look over here, it would tell you they have different masses, okay? And notice that the mass is in MeV. Oh, that reminds me of something we learned in this unit where E equals mc squared. So I can describe the mass of a particle based on the energy, the corresponding energy that it has. If it turned into energy, that's the energy that those particles have. So rather than describing the mass in kilograms, they use the energy from that binding energy type of formula. Okay, so remember 931.5 mega electron volts per U. All right, that tells us the mass of these quarks. So some are small, some are extremely large. Okay, I think that's even larger than a proton. So why are some small, why are some large? We're still trying to figure that out. But each of them have different properties. There's mass properties, there's charge properties, spin properties, which is a magnetic property, and of course they have different names. Okay, so the up quark, which is something up and down is something you're going to really need to know for your exam. These others are more rare. But the up quark has a charge of positive 2/3. Okay, that's something I want to focus on. The down quark has a charge of negative 1/3. Something we'll focus on in a second. Now, charm has all these on that row have positive 2/3. All these in that row have negative 1/3. And we'll see what happens when we combine them together. Combined, they give a property. Okay, so a proton has an overall charge of positive 1. So if I look at a proton, the proton is made from an up quark, and a down quark. The up quark is positive 2/3, and the down quark is negative 1/3. If I add all those together, I get a total charge of positive 1. That kind of explains why protons have a charge of positive 1. Okay? Now, neutrons are made from an up quark and 2 down quarks. If I add up their charges, all right, the total charge is 0. Makes total sense. Okay? So that's important. So when a proton converts into a neutron in a nuclear reaction, all that's happening is that a quark is changing flavor. And we'll get into that in a couple more videos. Okay? So I want you to stop here and go back to page 298, okay, and just really read the section on quarks, because you'll see that there's some examples of quarks coming together to make different types of particles other than protons and neutrons, stuff that we've never covered before. And those are called baryons or mesons, okay? And we're gonna try to figure that out in the next video.